Hello friends, I am Pratima. I welcome you all to my channel. I thank all the subscribers for supporting this and all viewers for watching these videos. So today again there is a very interesting inequality question. A, B, C, D all greater than 0. Prove that A over B plus twice C plus 3 times of D plus B over C plus twice D plus 3 times of A plus C over D plus 2A plus 3 times of B plus D over A plus 2 times of B plus 3 times of C is greater than equals to 2 over 3. So let x1 be your square root of A over B plus twice C plus 3 times of D, and y1 equals to square root of A multiplies B plus 2C plus 3D. Similarly, x2 equals to the second one, square root B over C plus 2 D plus 3 times of A, and y2 equals to B multiply C plus 2 D plus 3 times of A. x3 equals to square root of C over D plus twice A plus 3 times of B. y3 equals to C multiplies D plus twice A plus 3 times of B. And x4 equals to square root of D over A plus 2 times of B plus 3 times of D, and y4 equals to square root of D multiplies A plus twice B plus 3 times of C. So this left hand side is nothing but your x1 square plus y1 square plus x2 square plus x3 square plus x4 square. So I am applying now Cauchy's Schwarz inequality. Applying x1 square plus x2 square plus x3 square plus x4 square all multiplies y1 square plus y2 square plus y3 square plus y4 square is greater than equals to x1 y1 plus x2 y2 plus x3 y3 plus x4 y4 whole square. So x1 square equals to your A over B plus 2C plus 3D plus x2 square equals to B over C plus twice D plus 3 times of A plus C over D plus twice A plus 3 times of D plus x4 square equals to D over A plus 2D B plus 3C all into, this is your A into B plus C plus 2C plus 3 times of D plus B into C plus 2D plus 3A plus C into D plus 2A plus 3B plus D into A plus 2B plus 3C is greater than equals to x1 y1. x1 y1 is your, it will be A square root over. Next is x2, y2 will be b square root over c square root over plus d square root over and its whole square. So the left hand side, what is given in the question, equals to b plus 2c plus 3d plus b over c plus 2d plus 3a plus c over d plus twice a plus 3 times of d plus d over a plus 2 times of b plus 3 times of c is greater than equals to, this will be a plus b plus c d whole square, or if we simplify the left hand side whole multiplication, this will give us 4 times of ab plus ac plus ad plus bc plus bd plus cd. That means now to prove that a plus b plus c plus d whole square, 4 times of ab plus ac plus ad plus bc plus bd plus cd is greater than equals to 2. So a minus b whole square greater than equals to 0, a minus c whole square greater than equals to 0, a minus d whole square greater than equals to 0, b minus c whole square greater than equals to 0, b minus d whole square greater than equals to 0, and c minus d whole square greater than equals to 0. So adding all these inequalities, we get a square plus b square minus 2ab plus a square plus c square minus 2ac plus a square plus d square minus 2ad plus b square plus c square minus 2bc plus b square plus d square minus 2bd plus c square plus d square minus 2cd greater than equals to 0, or 3s times of a square plus 3 times of b square plus 3 times of c square is greater than equals to 2 times of 2ab ab plus ac plus bc ad plus bd plus cd. So 3 times of a square plus 3 times of b square plus 3 times of c square plus 6 times of ab plus ac plus bc plus ad plus bd plus cd is greater than equals to 8 times of ab plus ac plus ad plus bc plus bd plus cd. Left side is nothing but your 3 times taking common. It will be your a plus b plus c plus d whole square. So this is greater than 8 times of ab plus ac plus ad, bc plus bd plus cd, or a plus b plus c plus d whole square over here 4 times of AB plus AC plus BAD plus BC plus BD plus CD is greater than equals to 2 over 3. Hence proved. So writing the final result, this proves that A over A plus 2IC plus 3 times of D plus B over C plus 2 times of D plus 3 times of A plus C over D plus 2i's A plus 3 times of B plus D over A plus 2 times of B plus 3 times of C is greater than equals to 2 over 3. Thank you for watching.